video series on Comptia Network Plus course, Optical Time Domain Reflectometer. An optical time domain reflectometer (OTDR) is an optoelectronic instrument used to give you the skinny on optical fibers transferred, referred to as light meters. It works by putting out a series of optical pulses into the specific fiber you want to test. From the same end that sent these impulses, it collects and measures the light that is scattered and reflected among the length of the fiber. It then records the change in the amount of refraction at various points. This is a lot like the way an electronic TDR measures reflections caused by impedance changes in a cable that you're testing. The strength of the return pulses is incorporated into a measure of time, which also conveniently gives you the fiber's length. We use OTDRs to give us the following information: the fiber's estimated length, its overall attenuation including splice and mutated connector losses, the location faults such as breaks. Figure 1818 shows the output from an OTDR testing a fiber connection. The spike shows where a splice in the fiber is located, which has resulted in the signal being degraded. This is a very typical output. As the signal attenuates, you see a gradual but quick drop in decibels dB. Any connector will actually show a reflection, which, as mentioned, shows up as a spike in the OTDR output. The connector then creates more attenuation and loss of more dB. The more splices, the less distance you can run with fiber. Multimeter. A multimeter or multimeter testing, also called volt OHM meter VOM, is a multitasking electronic measuring instrument. Your average multimeter typically includes features like the ability to measure voltage, current, and resistance. Multimeters come in analog and digital versions, and they range from basic handheld devices useful for simple fault finding and field service work to more complex bench instruments that will give you measurements in a very high degree of accuracy. They can also be used to troubleshoot electrical problems in a wide array of electrical devices like batteries, motor controls, appliances, power supplies, and wiring systems. Figure 18.9 shows the output of the multimeter that I use to help troubleshoot my networks. Multimeters come in a lot of flavors with different ranges of features and prices. Cheap ones cost less than $10, but top of the line models can set you back up to $5,000. Spectrum analyzer. A spectrum analyzer is a tool that focuses on the physical layer, which will vary based on the type of analyzer, although vendors make these analyzers for both audio and optical signals. In most cases, spectrum analyzers are used to analyze wireless or radio frequency signals. Spectrum analyzer is primarily used to identify and measure the strength of radio signals that are present in the area. It can visually display these signals by frequency on the device. These devices are used to locate sources of interference that may impact the operation of a wireless network. Figure 1820 is a shot taken from the screen of a spectrum analyzer showing the relative use of each channel in the area. Toner probe generator. A toner probe is also called a tone generator, is a simple copper cable tester that is simple to use and can be used to trace a wire in a wall. It is a two-piece unit that's basically a tone generator, a probe, sometimes called a fox and hound wire tracer. This type of device consists of one part that you connect to a cable with a standard jack or to an individual wire with alligator clips that transmit a signal over the cable or wire, and another part that's a pen-like probe that emits an audible tone when it touches the other end of the cable, the wire, or even its insulating sheath. Most often you will use a toner probe to locate a specific connection in a punch-down block because, annoyingly, some installers run all the cables for a network to the central punch-down block without labeling them. They or you, if you're unlucky enough, then have to use a tone generator to identify which block is connected to which wall plate and label that punch-down block accordingly. This tool can identify a particular cable at any point between two ends, and because the probe can detect the cable containing the tone signal through its sheath, it can help you to locate one specific cable out of a massive cable spaghetti bundle in a ceiling conduit or other type of raceway. Just connect the toner probe generator to one end and touch the probe to each end in the bundle until you hear the tone. Figure 1821 shows a picture of my toner that I probe to find the tone on the other end of the cable. Also, by testing continuity of individual wires using alligator's clips, you can use a tone generator and probe to find open shorts and miswires. An open wire won't produce a tone at the other end. A short will produce a tone on two or more wires at the other end, and importantly, connected wire will produce a tone on the wrong pin at the other end. Sounds like fun to you? Well, not so much. It really takes a long time and it's super tedious. Worse, the whole process is almost prone to errors as the cable installation itself. You have to either continually travel from one end of the cable to the other to move the tone probe generator, or use a partner to test each connection, keeping in close contact using radios or some other means of communication to avoid confusion. So, considering the time and effort involved, investing in a wire map tester is just a much more practical solution unless you're nominally bored or really easily amused. Metrics. When using any tools discussed in the preceding sections, especially the network testing tools, collecting and comparing metrics over time is a valuable exercise. Once a baseline has been established for these metrics, you can determine when an issue has gotten better or worse over time. It also allows you to determine if measures you have taken to improve a scenario have done so. Error rate. One of the key metrics for which a baseline should be established is network error rate. Since network errors typically lead to retransmissions, then typically result in reduced throughput because each retransmission represents a lost opportunity to use that time slot to send new data. Bot set. A bot set is essentially a portable telephone that allows you to test analog, wet or dry lines and is used to monitor those lines. The most common type is shown in figure 1822, can both monitor and transmit. You see these all the time with the telco guys on the telephone lines. They use their bot sets to connect to telephone lines, test them, and even make phone calls. Another handy tool that will place of a bot set is a hound. This non-canine device is nothing more than an inductively coupled amplifier with a small speaker in a handheld tool. It's used to monitor the audio on a given line to verify that you have the right pair connecting it, and typically used with a toner probe. It will also monitor for noise. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, subscribing and give me a thumbs up. Thank you.